Hello, welcome back to another video. This is the last one of 6.1, so, well, unless there's homework questions, of course I'll make some videos about that as well. This was kind of a long section, so good work for getting this far in it. In this video, we're going to see an example of a system of equations where we have infinitely many solutions. And I think, I know we kind of struggled with infinitely many solutions before, but I think this matrix method of solving them makes them a lot more intuitive as to what you're really doing here, okay? And so what I'm going to do is I have this system of equations, okay? Right now I certainly can't tell that I have infinitely many solutions. So what I'm going to do is I'm going to put this system of equations, I'm going to write an augmented matrix for it. Okay, so let's see, what color should I do? Maybe blue. I'll do blue. Okay, so there's my bracket, and I'm just going to throw the coefficients in there. So -3, -5, 36, 10. Okay, then -1. There's no y in that one, so that one's just 0. 7, 5, 1, 1, -10, and -4. Okay, so this is our system of equations here. And so what I'm going to do here is I want to find the solutions of this. And so to do that, I want to put this in reduced row echelon form. And so I'm going to do my Gaussian elimination on it. And so first of all, we want to try and get this guy up here to be a 1. Okay. We want to have a leading 1 in our top left corner. That's what we want to have happen. Now, typically, when we've done this before, to get a 1 here, I've times the whole row by some number to get this to be a 1. And I certainly could do that. I could divide by -3 through this entire row, or times by -1/3 would be the same thing, right? The only issue is that not all of these numbers are divisible by 3, and so if I do that, I'll start getting fractions in my matrix, which is perfectly fine. It just looks kind of nasty. So if you'll notice here, I do have a 1 down here, right? And I've got a -1 here. Either one of those would be easier to deal with, to put a 1 up here than what we have. And so what I'm going to do is I'm going to switch. Remember, this is one thing we can do with our matrix is we can switch rows around. Okay, I can change the order of the rows of the matrix. And so in this case, what I'm going to do is I'm going to switch this row with this one so that I have a 1 at the top. Okay. So how I would write that using our little notation is I would say, well, I'm going to switch row 1 and row 3. Okay, so I'm going to switch row 1 and row 3. Okay. And so when I do that, the matrix that I end up getting out is just, well, I just switch those rows. Okay. So the first row the third row becomes the third row, or sorry, the first row. Oh my goodness. Okay, so the third row becomes the first row, and the first row becomes the third row. Okay, so I'm going to put in my third row now. Okay, and then -1, 0, 7, 5. That second row doesn't change at all. Okay, so why did I do that? So that I could have a 1 right here. Okay, that's one way that you can get that 1 right there, is just switch the rows so that you get 1. Otherwise, you can divide by a constant too. That works fine as well. It's just in this case that would kind of make this problem messy. Okay? So, I now have a 1 up there in that corner. So what am I going to do? I want to get rid of these guys. I want to get zeros there. Okay? I want to have zeros there. So let's look over here at this other board. So what am I going to do? I am going to use row operations and take this 1 and use it to cancel out the -1 and the 3. Okay, so to get rid of this -1, I just have to add 1 to -1 to get rid of it. So I'm going to do that first row and I'm just going to add it to the second row. Okay, so the first row won't change because we're just adding it to the second row. Okay, so 1 plus -1 is 0. 1 plus 0 is 1. -10 plus 7 is -3. -4 plus 5 is 1. Okay, so now we got a 0 in this spot below this leading 1. Okay, now the other thing we want to do is we want to get a 0 here. We want a 0 where the -3 was. So to use this 1 to get rid of that 3 or that -3, we want to do 3 times row 1 and we want to add it to row 3. Okay, because when I do 3 times this and add it to this, I will get 0. Okay, so 3 times 1 plus -3. Well, 3 times 1 is 3 plus -3 is 0. Okay, and then 3 times 1 is 3 plus -5 is -2. And then 3 times -10 is -30 plus 36 is going to be 6. Okay, and then 3 times -4 is -12, and then plus 10 is -2. Okay, so we did some row operations to get these two to be 0. Okay, and now we look at, we want to have, so we got our leading 1 here, 0's below it. So now we want to look for our next leading term, which is right here. Okay, and that is already 1. So we don't have to times by anything or divide by anything to get that to be 1. It's already 1. So that's just dandy. So now what we need to do is we need the stuff below it to be 0. So we want that to be 0. So I'm going to use this row with this leading 1 and get rid of this -2 here. Okay. So what am I going to do? I'm going to do, well, to get rid of the -2, I need a +2 times row 2 plus row 3. Okay, draw my matrix again. We get 1, 1, -10, -4. Okay, we've got 0, 1, -3, and 1. Okay, so the only thing that's changing here is my last row. So 2 times row 2. 2 times 0 is 0, plus 0 is 0. Notice how that didn't mess up your 0 that you already got. And then 2 times 1 is 2, plus -2 is 0. Okay, 2 times -3 is -6, plus 6 is 0. 2 times 1 is 2, plus -2 is 0. Okay, so you'll notice here that we have got this row of zeros down here, right? And so we realize now, like, my leading terms here are here and here. Okay, those are my leading terms. And there's no way I can get a leading term of a 1 here, right? Because there's just all zeros. And so this is actually the row echelon form, right? It's not quite reduced yet because there's this 1 up here above this leading one. So in order to get it reduced, what I'm going to do is I'm going to get rid of anything that's above the leading ones, and I go from right to left. So in this case, the furthest right leading one is this one, and so I want to get a 0 right there. Okay, so to get a 0 up there, what I'm going to do is I'm going to put this in reduced row echelon form. We're going to to cancel out this 1, I'll times this by a negative and add it up. Okay, so negative row 2 plus row 1. Okay, and so when we get that, well, what will happen? My second row stays the same. Okay, and then my last row is still just zeros. Okay, when I do negative row 2 and I times that all by a negative and then add it up, negative 0 is 0. Add to 1 is 1. Notice we didn't mess up our 1. Now negative times positive 1 is negative 1. Plus 1 is 0. Okay. Negative 3, positive 3. Add to negative 10 is negative 7. And then negative 1 plus negative 4 is negative 5. Okay. So there we go. This is reduced row echelon form because we've got, here are my leading ones. There's zeros above and below them, right? This other stuff, they aren't leading terms, right? There's no other leading terms in the whole thing, so this is reduced row echelon form. Okay. Now, how can I see that there's going to be infinitely many solutions? It's because there's not a leading one for every variable. Okay, and I'll show you what this would why that is in terms of our equations. So let me get a new board for us. Get that lined up there, and then get some fresh space. Okay. So let's translate these back into equations and kind of see what happens when we do that. Okay, so this column, the first column, corresponds to x, the second column is y's, the third column is z's, and then these are the things on the other side of the equal sign. Okay, so the first equation translates into x plus 0y, so there's no y's, and then minus 7z is equal to negative 5. Okay. Now, for the second row, we've got 0x plus 1y, and then minus 3z is equal to 1. For the last equation, we've got 0x plus 0y plus 0z, which is just 0, is equal to 0. Okay, so that one really doesn't matter because that's true. That's just true everywhere. Okay, but these other two do matter. You need both of them to work in order for this equation to have a solution. Okay, And so essentially what you can do here is once you have your equation or your matrix in reduced row echelon form, well, this is the simplest these equations can be. And so if I solve them for the leading variables, the ones that correspond to the leading ones, okay, I'm just going to solve for x here. I get x equals -5 and then plus 7z. And y would have to be equal to just adding 3z to both sides. Well, a 1 still, and then plus 3z. Okay? And so you can see whatever value of z you pick, you can pick any value of z that you want and plug it into these equations and get a solution, okay, at that z. And so there are infinitely many solutions, and how we would write our answer is just, well, it's not all real numbers, right? Because they do have to satisfy these equations here. But my x value, my first coordinate, is going to be -5 plus 7z. My second coordinate is going to be 1 plus 3z. And then z is my third coordinate, is just z. Okay? So this would be kind of my answer. In the book, what they do is they write their answer a little differently, but it's the same thing. They just use a different variable for z. They set z equal to a variable t, and that's kind of convention, but I don't care one way or the other. Okay, so they just replace everywhere there's a z in this equation, they just replace it with t. Okay, and that gets across the exact same idea. Okay, so this would be our final answer here. Either one works, whichever one is easier for you to understand. Okay. So, hopefully that kind of helps you understand when you have infinitely many solutions, how you go about solving this. And you tell that by looking at, like, do you, in the end, right, can you solve for actual values of the variables, or is there not enough information? In this case, we don't get any number for z, right? If you do get numbers, right, for x and y and z, then you're done. There's just that one solution. But in this case, there was equations for x and y in terms of z, so there's infinitely many solutions. Okay. So hopefully that's helpful. Let me know if you have questions through email. I can try and help explain things more. But I will see you in the next video. Hope you guys have a good spring break. Stay safe. It is scary out there for sure. So love you all. Hope you're doing well. We'll talk to you later.